Well, okay, so this is a story of the exploration of numbers that span from ancient Babylonian times through modern times. And it's interesting in that it is an example of the exploration of numbers for their own sakes. And I wanted to just give you a couple of other sort of categories of numbers that people have investigated. They found interest in them, besides these squares and sums of squares. Other ones that are interesting are called perfect numbers. The ancient Greeks thought that a number was perfect if you took its factors, if they added up, the factors less than it added up to the number itself. For example, the number 6. The number 6 is equal to the sum of its factors. 1 divides evenly into 6, so 1 plus 2 plus 3 is equal to 6. Another perfect number is 28. 28 is equal to the sum of its factors. 1 plus 2 plus 4 plus 7 plus 14 is 28. People have been looking at these perfect numbers all through history, from ancient Greek times until now. And the one discovered in the year 2001 is written there on your screen. It's 2 to the power of 13,466,916 times 2 to the power of 1 bigger than that minus 1. That number has 8 million digits. If you wrote it out, it would have 8 million digits. If you could write it in some volumes, it would take more than 2,000 pages of small type to type that number. But that number has the property. That number with 8 million digits has the property that, in fact, if you took all of its divisors, all the numbers less than it that divided evenly into it, and you added them up, you would get this number back again. Now, there's sort of an amazing thing. Well, but what really is interesting about the perfect numbers is not so much the ones that we know, or the fact that there are many we don't know whether or not there are infinitely many of them. So this is the 39th one, but nobody knows whether there are any bigger than that and whether there are infinitely many bigger than that or not. Also, nobody knows whether there's any odd perfect number. Nobody knows. So this is